Hi, this video is about the concentration of solutions. We are talking about the amount of our solute that is in a given amount of the solvent. Well, let's just review some vocabulary. A solution is a homogeneous mixture, and it can contain one or more solutes in a given solvent. Our solute is what's present in the least amount, and the solvent is what's present in the most amount. In this video, our solvent is always water, so we have aqueous solutions, and we're only going to have one solute. So when we describe solutions, we can use words like dilute or concentrated. And what a dilute solution would mean, it would mean that there's not a lot of solute in your solvent. Something that's concentrated would have a lot more solute in a given amount of a solution. Well, concentrated and diluted are great words to describe the solution, but we want something more quantitative to describe how much solute is in our solution. And so we have a unit for that, and it's called molarity. Molarity is abbreviated with a capital M. It's the most common unit used to describe the concentration of solutions. So if you hear someone say, well, what's the concentration of a solution? They're usually looking for the molarity. There are other concentration units, but this is the most common one. Molarity, its definition, and this is what you need to remember, and we're going to be using over and over. Molarity is moles of solute per liter of solution. Moles of solute per liter of solution. If we had, and you've seen this on all of the bottles that we've been using in labs, you would see like 1.00 capital M HCl. Well, what we would say is 1 molar hydrochloric acid. We wouldn't say 1 molarity. We would say 1 molar HCl. Very concentrated hydrochloric acid could be 12 molar. This would be really dangerous. So 12 molar hydrochloric acid. That's how you would say that. So now in the lab, when we have reagent bottles, you shouldn't just be saying, hey, pass the HCl. You should be saying pass the, and you should describe the concentration. 1 molar HCl or 12, well, I'm not going to have you working with 12 molar hydrochloric acid. All right, well, how do we calculate molarity? Well, we just have to remember, we have two things in this concentration unit. We have our moles of our solute. A lot of times the solute might be given to you in grams, but that's not a problem. We now know how to convert grams to moles. So if you are given grams of a solute, you're going to divide by the molar mass to get moles. And so here you'll have moles of solute. And then you're going to divide it by the liters of solution. Now they'll give you a volume of a solution, but if it's given to you in milliliters, just remember that a milliliter is 1 times 10 to the negative third liters. So in order to convert milliliters to liters, you take your milliliters and you will be dividing by 1,000, and then you will get liters. In other words, you are going to be moving your decimal place 3 places to the left. All right, well, let's practice. Let's go ahead and calculate the molarity of a solution. So what is the concentration, or what is the molarity of a solution that contains 90 grams of sodium chloride in 3,500 milliliters of solution? Well, step 1. Let's go ahead and convert those grams of sodium chloride into moles. Sodium chloride is our solute. We need to get it into moles. All right, so we had 90 grams of NaCl. Grams to moles, I hope you're all thinking in your head, we need to divide by the molar mass. So 1 sodium plus 1 chlorine is 58.45 grams in a mole. So 90 grams divided by 58.45 gives us 1.54 moles of sodium chloride. Now, step 2. Let's get our volume, milliliters, into liters. And so what we do, we had 3,500 milliliters. We're going to divide that by 1,000. In other words, we're moving that decimal 3 to the left, and that gives us 3.5 liters of solution. All right, and then the final step, to get the molarity, Molarity's definition is moles per liter. So we're just going to divide the moles that we got in step 1 by the liters that we got in step 2. So 1.54 divided by 3.5 gives us 0.44. So we have a 0.44 molar solution of sodium chloride. Okay, we're going to stop the video now, and you're going to do 3 practice problems that is related to calculating the molarity. Okay, welcome back. Now we're going to calculate moles using molarity. All right, now remember, molarity is moles per liter of solution. Well, if we took this molarity and we multiplied it by a volume in liters, look what happens. The unit liters cancel and we're left with the unit moles. So molarity times volume gives you moles. And you know how important moles are in chemistry. This is just another way to get moles. Molarity times volume. So here we go. We've got 800 milliliters of 0.25 molar nitric acid. How many moles of nitric acid do you have? Well, our molarity, and I tell my students, when you see a capital M meaning a molar solution, there's some hidden information in that. Go ahead and write down moles of nitric acid per liter. All right, now we have our molarity, and we are going to multiply that by our volume in liters. 800 milliliters divided by 1,000 to give you liters. Just move that decimal 3 to the left. There we go. So molarity times volume in liters gives you moles. So 0.25 times 0.8 is going to give us 0.2 moles of nitric acid. Now, sometimes a problem will want you to take it one step farther, and this is going to be reviewed. They may say, how many grams of nitric acid is that? And that should not be a problem after our last unit. You have 0.2 moles of nitric acid, and to get to grams, you have moles to grams. You are going to multiply by the molar mass, and the molar mass of nitric acid, 3 oxygens, 1 nitrogen, and 1 hydrogen is 63.02 grams. I got that molar mass by just 3 oxygens, 3 times 16 plus 14.01 plus 1.01 gives us 63.02. And if they had asked for grams, we would go ahead and multiply 0.2 by 63.02 and come up with 12.6 grams of nitric acid. All right, go ahead and stop the video now and do problem set 2 on the handout, where you'll be calculating moles or grams given a volume and a molarity. Okay, welcome back. The last calculation we're going to learn to do using molarity is we're going to calculate a volume. Now you're going to be given a solution of some known molarity, and they want you to deliver a certain amount of grams of a solute, or maybe even moles. And so you're going to have to figure out how much of that solution do I need, or what volume do I need to deliver that amount of solute. So let's look at a problem. Let's say you need 23.4 grams of potassium chromate. But all you don't have like a solid where you can just weigh this out. You have a 6 molar solution of potassium chromate. Well, what volume of your solution will you need to give you that 23.4 grams? Well, in this problem, the first step is to convert the grams to moles. So we're going to convert 23.4 grams of potassium chromate to moles. And again, we are going to divide by the molar mass. And a mole of potassium chromate is 194.2 grams. 2 potassiums, a chromium, and 4 oxygens add up to 194.2. And when I do that, I get 0.120 moles of potassium chromate. Okay, so that's great. Now we have the amount of moles needed, not grams. So we've converted our grams to moles. That's the first thing you do. Okay, and step 2, if you take your moles and if you divide by the molarity, and it's 6 molar, or in other words, it's 6 moles in 1 liter. So we are dividing by the molarity. Look what happens. The moles cancel and we're left with liters. And our answer is 0.02 liters of solution. So in other words, if you wanted to deliver 23.4 grams of potassium chromate, you would have to use 0.02 liters of the 6 molar solution. And to be a little more lab friendly, that would be 20 milliliters of the solution. All right, now stop the video again, and this is the end of the video, and do the problem sets number 3 to practice calculating volumes with a molarity. Have a good night.